we're here today to discuss dynamic test generation, specifically with OpenAPI Spec 3.0. You can see my little hashtag down there at the bottom. What does that mean? That means stop writing tests. So what does stop writing tests mean? Before we go into that, here we go. A little bit about myself. My name is Alan Helton. I'm a software engineering manager at Tyler Technologies. I've been in software since 2012. Started off as an engineer and worked my way up. Now I'm a manager over some cloud native teams at Tyler Technologies, having a ball, loving APIs. So I'm a big proponent of APIs. I work with them every single day. And I'm here today to talk to you about how you can do what we do at Tyler and generate your tests, save a lot of time, focus on business logic. All right. So for our talk today, what's on the agenda? So we're going to talk about what dynamic test generation is. We're going to talk about what a REST API looks like inside of Postman. We're going to talk a little bit about OpenAPI Spec 3.0 because that's really the key to all of our test generation. We'll dive into how test generation works, and then we'll end with a demo. We're going to see it in action, have some fun with that. All right. So what is dynamic test generation? Sounds complex, sounds scary, but boil down what it means. It means no more writing tests. The tests are built for you from your OpenAPI spec and run on demand. That means no more managing large collections of tests that may or may not get stale over time. It means that your testing suite grows as you develop your APIs. So as you build more APIs, you automatically get more coverage. Without having to spend any precious developer time. We're going to go and talk about the types of test generation. There's actually several kinds. You can see over on the right hand side we have a collection run. That's a contract. That's the contract test generator. What that does is it validates that your OpenAPI spec does what it says it's going to do. Does it take all of the schemas that you've said the request bodies have, and does it return what it's expected to return? Does it return the same response codes it's supposed to return? And are all the endpoints that you've defined, are they valid? Do they work? We have performance tests. This is a big one. I know it's a hot topic for QAs everywhere. Does your API average what you want it to average? And what is the slowest run? We can do that in a generated fashion. We don't have to build all these performance tests and maintain them over time. We can just generate them with our OpenAPI spec. Next, we have security tests. Probably one of the most important things that you can do when you're developing public APIs, or really just APIs in general, is make sure that it's locked down. You don't want people to get in and have an exploit and have your company in the news everywhere. That's the last thing anybody wants. So you can automate and guarantee security tests that run the full gamut of your API. Next, we have breaking changes. Breaking changes, again, it's a hot button topic. It's not something that people generally talk about, but when it happens, people talk about it a lot. So that's for maintaining live APIs. If you push a change up that would break an integrator, maybe you know, maybe you don't know that it's happening, but what you want to do is not have that happen. So breaking changes, we can automatically test to see, are we doing something that we shouldn't do to a live API? The last type of test that we can do in Postman are test suites. So that's tests like running through business workflows and validating that real life scenarios work. That's not actually something that we can test generate. I wanted to touch on that lightly because that's a very important one, and that's not one that can be generated. Over time, I'm sure we'll get there, but as of right now, we're really going to focus on those top 4. So I want to talk to you and give you a little backstory about why I'm here talking to you about this in the first place. So like I said at the beginning, I'm a software development manager. I run some of the cloud native teams over at Tyler. And during our daily stand-ups, I was noticing there was a recurring update. I would hear time and time again, yeah, the development's done, but I'm working on the security tests. So I'm working on the contract tests in Postman. And I would hear that day after day where developers were spending the entire day building up the automated tests. And as a manager who's responsible for making sure that the work gets done, that's not something that you want to hear day after day. So what I did was I took an analysis. I started looking at the contract tests that they were building. And I noticed that yes, they're there, and yes, they're good, but they didn't have very good coverage. What they were doing was building out happy paths. They weren't testing out all of the scenarios that I really would have liked. And in addition to that, they were spending a lot more time than I would have liked. To break it down, this is kind of what happened. This is kind of what it looked like before we had test generation, where developers were spending about 30 to 35% of their time every story building contract and security tests. And best case scenario, we were getting about 30% coverage. Again, happy path, different code paths, but definitely not everything we needed to test. Once we switched over to test generation, we didn't spend any time writing tests, and we got 100% coverage. We included the test generation in our CI pipeline and automatically get that testing. We can see in our pipeline every test that runs, and if any of the assertions fail, it rolls back, build fails. So we're getting in an extreme amount of testing really for free, which means that the developers get to do what the developers like to do, and that's write code. That's focus on solving business problems, and that's focusing on actually building software. And that means that I get to do what I like to do, which is telling people what to do. So happy story for everybody. What we're going to do is we're really going to start our whole adventure here by looking at what a REST API looks like in Postman. So this should be a screen that's familiar to everybody here. This is a request in Postman. And you can see this is my fake business, but real API, Gopher Holes Unlimited. Focuses on tracking gophers and holes. And we're going to go and take a look, because there's a lot on this screen. It's pretty data dense. And we're going to see exactly what each of these pieces mean as they relate to a REST API. So the first thing we see, that's the base URL, Gopher Holes Unlimited. That's every single API call, every endpoint is going to start with that. That's very important. Tells the API where to go, what environment to do. Next, we have the HTTP method. These are a set of standard verbs that show API intent. A post will generally add new data into the system. A get will retrieve data from the system. A put will update data in the system. Stuff that we all know, but very important when it comes to the definition of an API. Next thing we have, the path. What API are we actually hitting? This is specific to each endpoint, and this is how we get the API to do what we want. Within the path, we have parameters. So you can see in the URL there's a colon with Gopher ID. That's a variable. That's a parameter, a path parameter. That means that we can dynamically declare what that URL is going to be. Again, very important. The next thing we have is our request body. So you can see down here my status trapped JSON payload, updating that Gopher with trap status. So this is the data that we're actually passing into the API. Anything that we can't fit into the URL is going to be passed to the body. And lastly, we have the response. So you see the HTTP status code at 201 stands for created. This is, again, a standard. It's an industry standard thing. And then down at the bottom is the response payload. So this is the answer back from the server. So we can chain things and understand that things worked. Okay, now we're going to talk about OpenAPI Specification 3.0. This is really the key to everything that we're talking about for test generation. This is what OpenAPI spec looks like from within Postman. Postman has API features that let you put in your OpenAPI spec in YAML or JSON and define your entire API. That's what it looks like. But we're going to talk about really what is OpenAPI spec. And to put it simply, you can really think about OpenAPI spec as essentially like the blueprint of a house. It's the definition. It's not the real thing, but you can learn everything everything that you need from it. like where are the windows, where are the doors, where are the secret tunnels, where's the panic room, where's the chimney, what color are the walls. Everything about that house is defined on that blueprint. You can't live in the blueprint. You still have to actually build the house, but you can learn everything about it. And it's the same thing with OpenAPI Spec. OpenAPI Spec is a definition of your API. You still have to go and build it. You have to implement the API. But as far as the definition goes, that is what it is. It's a definition. So now what we're going to do is we are going to talk about the components for a REST API. So the first thing I'm going to do is I'm going to bring back those components that we just saw in Postman, the pieces that we need to execute a request. So we have our six items here. We're going to talk about where they are and what they are inside of an OpenAPI Spec definition. So first thing, base URL. Where is that in OpenAPI Spec? At the very top, typically you have a server's element, and the server will let you say, this is this environment, and this is the base URL. This is that environment, this is that base URL. Very simple, very easy, incredibly valuable when defining your OpenAPI, so people know where are the multiple environments. You know, most APIs will have a test environment, have a production environment. Sometimes they have a development environment, but you usually have at least two. So we need to know where we're going. Right here, what I'm showing you is the definition of an endpoint in OpenAPI Spec. The first thing we're going to look at is the HTTP method. For each endpoint, you can define a certain set of methods and the definitions around them. So you can see here, we've defined a put. We have the actual path. So this is that piece after the base URL. So we have the base URL /gopher/gopher ID. So things that you would be able to do here, update a gopher, get a gopher, delete a gopher, things like that. But you can see we have a whole bunch of different details for that path defined below. Next thing we have is parameters. You can see in the example that we have a ref in there, which just means I'm referencing another place in the OpenAPI Spec. The reason you would do this is so you don't have to keep typing it over and over. What you want to do is, like code, you'd want to define it one time and use that throughout your OpenAPI Spec. So what does that look like? Well, glad you asked. Here's what it looks like. So down usually at the bottom of your OpenAPI Spec, you have your parameters defined. So you can see here, this is the gopher ID ref. So we can say this is the name, comes in the path, it's path variable. Here's the description, and then here's an example of what that is. Next thing we have is the request body, arguably one of the most important things. This is what is the data that's allowed to be passed into that API. Again, you can see here that we have a ref to another piece down below. You can also see that we're defining the content type. This API, Gopher Holds Unlimited, is a JSON-based REST API, so you can see content is JSON. So loading up, this is what the request body looks like. It's actually part of it. There's a lot of different things you can track on a Gopher, but what you can see here are the required fields. If you want to add a Gopher into the system, you have to have the name, picture, and location. And then beneath it, you have the other fields that you can track. You can see specifically in my definition, I have a description and an example for every single field, which is critical to the test generation. We'll talk about that in a little bit. Lastly, you have the responses. What are the HTTP status codes I can expect when I call this endpoint? What happens in any case of a failure? Do I get 400? Do I get a 401 for authentication? What happens when it's successful? Do I get a 204? Do I get a 201? Do I get a 200? You can define all of them per endpoint in your OpenAPI Spec. And in addition to that, you can define what the body of that response looks like. Now, my example here is a 204 no content, meaning I wouldn't expect anything in the body. But that's not a very good demo, so I'm actually going to show you what a created looks like. So whenever I add a new thing into the system, I would expect an ID back. I'd expect that to come back and be in that kind of a format. All right, so I see 6 components on the left-hand side, and I see 6 check marks. What does that mean? That means we have everything that we need defined in the OpenAPI Spec to run a request in Postman. High five. So now we're going to talk about specifically how the test generation works. This is we're not going to get too technical into it. We're going to talk about the high-level pieces. So test generation, 3 steps. 1, build. we are going to define what our tests look like at the very, very beginning. We're going to load your OpenAPI spec. We're going to develop an execution plan, and we're going to be ready to go. Step 2, execute. We are going to actually run and hit your implementation of the API given what you defined in your OpenAPI spec. And 3, we're going to verify the results. We're going to check to see, did we get the right response? Did we get the right response code? Did we get the right response body? What's there? And depending on the type of test generation that we're doing, maybe we're going to test different things. Maybe we're going to see how fast it was, or maybe we're going to see what the response body actually was, what the payload is. Very fun. Lots of different things that we can do with it. So what we're going to do is we're actually going to go and look a little bit in more detail at each one of these steps. First step being build. So when we're going and we're executing a test generation run, the very first thing that it does is gather test parameters. We have in the test generator an environment, and the environment has a whole bunch of different variables that define details about the run. This is what my API key is. This is the environment that I want to hit. Do I want to hit test? Do I want to hit prod? Some governance things. It loads all that and it gets ready to prepare the run. The next thing we're going to do is we're actually going to load the OpenAPI spec. So we use the Postman API to load your API. And what it does is it goes and gets the most current version of that OpenAPI spec. Next thing we're going to do is we're going to validate the schema adherence. So what that means is at this layer on pretty much every test generation, we're going to add a layer of governance in there, because what we want as an organization, really any organization, is to produce APIs that are consistent. So I don't want one dev team building APIs that look one way and another dev team to build APIs that look another way, because we work for the same company. So to our customers, it should feel like it's from the same company. This is our opportunity to kind of toss that in and make sure that we're consistent. It also verifies that we have all of the criteria needed to run test generation. So like I said before, one of the things that's really important is having examples defined for all of your parameters. When we're doing test generation, one of the main things that we want is to have meaningful request bodies go into your API. So the developers or whoever's defining your API spec, their responsibility is saying, this is a real life example of what you could pass in there. And that's what we're going to use when we build and test your API. All right, the last step in the build phase is build an execution plan. And this is, again, it's different based on the type of test generation that we're doing. For a contract test, what it does is it goes in, loads all your endpoints, loads the request bodies, and it generates examples based on your examples. So it says, okay, given what you said, I should be able to create a request body that looks like this. And what it does in the contract test is it builds that, then it starts taking stuff away. It says, you said this was required, so what happens if I don't pass it in? Is it actually required in your implementation? What if I pass in a blank value? What if I delete this object entirely? It's going to go and it's going to do this for every property, for every endpoint you have defined in your OpenAPI spec. It's a lot. But again, we don't have to do that. This is being automatically generated every time you run your code. Okay, so that wraps up the build phase. The next phase is the execute phase. So what it does is it just pops the first test off of your execution plan. And what it's going to do with that is it's going to see what it has to do. And it's going to take what it has to do and say, okay, well, let me programmatically set what the HTTP method is, what the path is, what the parameters are. This is what the body should look like. You can do everything like that in code in a pre-request script. So that's what it's going to do. It's going to take all those details and set you up. Once it sets all the request details, it's going to go and it's actually going to run your API. It's going to execute your actual implementation based on your definition criteria. And as far as execute goes, I mean, that's about it. It's going to take the test spec and run it for you on your behalf, which leads us to the last step, which is verify. So in the contract test generator, what it does is it says, given this request body, I would expect this to succeed. Or I didn't pass in a required variable, so I would expect it to fail. The very first thing it does is test. Did it succeed or did it fail? The next thing that it's going to do is it's going to disregard that part. It's going to say, okay, well, regardless of whether it was supposed to succeed or fail, is the status code that I got allowed based on the OpenAPI spec? If I said that I can have a 204, is that the response that I got? It's going to verify that you've implemented exactly what you said you were going to implement. The next thing it's going to do is it's going to verify the response schema against what you define in your OpenAPI spec. So you said for this endpoint, for this response, this is what the response body should look like. We have that in the OpenAPI spec, and what we use is AJV, which stands for another JSON validator, to go in and verify that it actually is that. It's going to go in and it's going to say, okay, this is what it should look like, does it? Now that doesn't do value tests. What it does is it just is a schema test. Are these variables here? Are the required ones there? Are they this data type? The last thing that we're going to do in the verify step is we're going to save off workflow variables. This is actually a newer thing that we implemented in the test generator, where you can use IDs from entities that were used in your generated tests in subsequent generated tests. Meaning, if I create a new gopher in the system will return the ID for me. And I can take that ID and use it in other tests. So I can use it in the get, I can use it in the update, I can use it in the delete, which means that I can have these test generation suites that run and clean themselves up. I don't have to seed data into the system. I can actually just let it run and let it ride, which is great. So after it does all that, it'll look to see, are there more tests to execute? If yes, let's go back to the execute phase. If no, then let's wrap it up. Okay. So now that everybody is properly excited, we're going to go and we're actually going to demo it. We're going to see, what does this actually look like? So this here is Gopher Holes Unlimited OpenAPI spec. We have our definition. This is in YAML. We have our endpoints, our HTTP methods, our descriptions, our request bodies, and our responses. We have everything in here that we need in order to generate and execute the test generators. So the first thing we're going to do, let's see what the contract tests do. So we're going to run it. And the first thing it's going to do, it's going to run those governance layers. It's just going to see, do I have this API? Do all of the properties have descriptions? Do they have examples? Are the descriptions meaningful? And then what it's going to do, as you can see here, it's going to go and run all of these different permutations against every single endpoint. And you can see as it scrolls, it's going through posts, it's going through puts, it's going through gets. It's all dynamic and it's hitting everything. You can see all the tests that it runs for every execution. So you can see here on the get for holes/hole ID, we expected this to work and it did. So that's great. It gave a 200 response, and 200 is allowed in our OpenAPI spec. Great. And then based on the response body that I got, that matched the schema that was defined in the OpenAPI spec. You can see, you know, it does that a whole lot. I didn't have to write any tests, and it went and ran 375 assertions. I only have, I think I have 7 or 8 different endpoints in this API. Next thing I want to show you, performance tests. I said earlier, this is something that a lot of people seem to really have high value in. A lot of people spend a lot of time building performance tests. So what we can do based on the OpenAPI spec is dynamically generate them. There's not much to them, so I'm going to run it. And while we're waiting for those to run, I'm going to show you what the generator environment looks like. Some of these variables that we can set before each run. So you can see these are my governance things that I have set: min API count per workspace, the max API count per workspace. What workspace am I testing? More governance, more governance. Down here we have what server, what test am I going against, which environment. Down here I have my performance test variables, and you can see that for each endpoint in my API, I want to run it 10 times. And I want to make sure that the average response time for each endpoint is 500 milliseconds or faster. And for the slowest executions, I want to make sure that it's 1200 milliseconds or faster. So in our performance test generator, we did just that. We iterated over every single endpoint 10 times, gathered up the execution times for every single one. And then down here at the bottom, we broke it down. So the post on /gophers, the average execution time was 200 milliseconds. Great, that's less than 500, perfect. Slowest execution time was 432 milliseconds. Great, that's less than 1200. And the last thing that we have in here is taking the average success rate. It's not a very accurate performance test if your API fails every time. So what we do in here with the performance test generator is just make sure that we have at least half of our calls be success. And the success is defined as a 200 something response code. The next thing that I want to show you is breaking changes. And again, people don't often talk about them until they actually happen. So a breaking change is going to be something that would, whether it's on purpose or on accident, break your integrators with a live API. So that's maybe something like adding a new required field, or taking away an existing field, or stopping support on a specific response code. Those are things that we can't do because you can never tell what your integrators are doing with your API. You can see here that I have 121 assertions that ran against it, and I did not break anything. It's going in, it's checking a whole bunch of different stuff against the breaking changes, which is great. But to show you that I'm not just blowing smoke, we're going to go and make a breaking change. And breaking changes really come at the definition level. So what we're going to do is we're going to change the OpenAPI spec. We're going to say that for a gopher, it's been very confusing and nobody knows what types of gophers there are out there. So we're going to go and add a required field. We're going to say now type is required. So every time you add a gopher into the system, you have to also include type. When I go back and I run the breaking change generator, it's going to compare my current API spec versus the previous version. So if we look in here, still run 121 assertions, but 2 of them failed. I click on the failed, you can see that it expected there to be no new required fields for /gophers, but type is there now. So I either have to go in and version this API endpoint, version the whole API, or take that back out. In addition, because everything is driven off of the definition, we can actually go and verify that the contract test generator works or doesn't work. So I'm going to run it again. And because I changed the definition, but not my implementation, things should start breaking. You can see as it's running, it's starting to build up these failed tests because it expects type to be a required field. So if it doesn't pass type in, it would expect it to fail. And you can see that when I don't pass type into the /gophers endpoint, I expected it to fail, but it didn't. I got a 201. I expected a 400, but I got a 201 instead. And that's kind of happened down all this. So I didn't pass type in, I passed it in as blank, and it got me. It busted. What I said was the case. What I said was the definition of the API is not actually what I have implemented. So I'm going to go in here and say, yeah, that was actually a mistake. I am not going to require type. I'll go back. I'll run the breaking change generator again. We'll see that, yay, nothing's broken again. And one more time, we're going to run the contract tests just to make sure that our definition matches our implementation. And as we go, running the tests, run, everything's starting to look good again because what we've implemented is actually what we said we did. Very cool, very cool. And as I start to continue to add endpoints into the API, these tests come for free. So all I have to do is just run the request again. I could put it in my CI pipeline and have that in there as well. So every time I push a code change, it verifies, runs Newman, verifies that it is what it says it should be. Okay, well, that is everything that I have for the demo. And I'll open it up to some questions and answers. What do you guys have for me?
Hey, Alan, we had a couple of questions around how did you actually generate those tests from the spec?
Yeah, that's a great question. Short answer: a lot of JavaScript. A little bit longer answer. So we use the Postman API to load your spec into JavaScript or into JSON. We actually load what the definition is, and use JavaScript to pull the examples from everything. So we can parse each endpoint, each ref, each field. I'm not going to go through the code, that'll be messy. And pull it and build up these individual request bodies. Based on the request bodies, we can then go and make some assumptions because we know these are the required fields that should be in here. Let me start taking them out. Let me start messing with them and just add those onto the execution plan.
Yep, cool. A question, can I set this up tomorrow for my OpenAPI specs? Do you, I think Kin actually shared, or Steve, Ryan, posted to your GitHub page with this. Do you have plans on making this a public workspace?
Yes, I am. Actually, I'm waiting on a feature to come out for public workspaces to allow personal workspaces when you're a part of a team. That's really the only thing that's preventing me from doing that. So I don't want to put this on Tyler Technologies public workspace. I'd rather put it on mine, just to keep the context different. They're all of the generators are currently in GitHub. I believe the breaking change generator is actually a template inside of Postman, not in GitHub, but they're all publicly available now.
Cool. All right, and Ken posted a blog post with more information. We're past time for this session. Alan, thank you. For those who are still on, if you hop into Slido, there's a quick survey about Alan's session, if you would fill that out. I think we have a little bit of a break before kind of our last round of sessions. I think there's a self-care workshop that you can go to. Otherwise, you can get lunch or breakfast or dinner or some form of snack, depending on where you're at in the world. So Alan, thanks again. I appreciate it. And I'll look to find everybody on the flip side of the break.
Absolutely. Thank you, everybody.